SOE requirements favored compact shoulder-fired weapons. Pistol concealment limited effective engagement distance. A briefcase-sized package drove overall geometry. Station 9 handled development under wartime secrecy. The weapon was later nicknamed Welgun. It fired the 9x19 mm cartridge. Simple blowback operation reduced machining complexity significantly. A fixed firing pin simplified bolt production. Closed bolt firing improved first shot stability. A tubular receiver allowed rapid lathe work. Receiver tube diameter matched bolt clearance needs. Bolt mass balanced safe cyclic rate. Recoil spring length fitted inside the receiver. Spring guide prevented kinking during compression. A short barrel reduced overall stowed length. Barrel length was documented near 9 inches. Barrel steel used standard ordnance grades. Sets rifling used conventional 6-groove patterns. Chamber finish required smooth extraction surfaces. A simple barrel nut retained the barrel. Threads needed alignment to preserve headspace. Headspace was set by barrel shoulder position. The muzzle accepted no standard British bayonet. A basic front sight was pinned to barrel. Rear sight was fixed for short ranges. Sights favored coarse alignment over precision. Magazine compatibility influenced feed geometry decisions. The magazine type followed Sten patterns. Sten magazine lips required consistent heat treatment. Magazine spring strength affected last round feed. Magazine catch location drove grip placement. The magazine inserted ahead of trigger group. Magazine insertion angle reduced overall height. The feed ramp was minimal and steep. Ramp machining used a single cutter pass. A polishing was specified after machining operations. Extractor design copied simple blowback precedents. Extractor claw geometry needed sharp engagement. Ejector was a fixed projection in receiver. Ejector timing depended on bolt travel distance. A folding stock enabled briefcase carriage. Stock arms used stamped steel components. Hinge pins required hardened bearing surfaces. Locking detents prevented accidental stock collapse. Butt plate was small and minimally contoured. Stock length matched average British soldier ergonomics. Length of pull was short by modern standards. The pistol grip was integral to the frame. Grip angle was upright to save space. Grip panels used simple wood or molded material. Fasteners used standard slotted screws throughout assembly. Trigger mechanism was simplified for manufacturability. Sear surfaces needed careful stoning for safety. Trigger pull weight was kept moderate. A manual safety blocked trigger movement. Safety lever travel was short and stiff. Safety engagement was positive but small. The cocking handle folded to reduce snagging. Handle slot allowed bolt retraction during assembly. Slot edges required deburring to avoid cuts. A dust cover was not always provided. Open slots invited grit and fabric lint. Case carry increased exposure to debris. The takedown layout used separable major parts. Receiver assembly detached from stock module. Barrel could be removed for packing. Magazine was carried separately for concealment. The carry case housed components in cutouts. Foam or cloth inserts reduced rattle noise. Cutout tolerance directly affected retrieval speed in practice. Assembly was intended in under 1 minute. Field assembly required practiced hand motions. Incorrect order caused binding at interfaces. Barrel seating errors changed point of impact. Loose barrel nuts induced vertical stringing. Bolt return speed changed with lubrication choice. SOE specified minimal visible oiling for concealment. Dry operation increased friction under fouling. 9mm ammunition varied across theaters. Hot loads increased bolt velocity and wear. Weak loads caused short stroking failures. Magazine quality strongly dominated reliability outcomes during trials. Worn feed lips produced nosedive stoppages. Bent magazines routinely caused double feeds during firing. Sten magazines were already notorious for issues. Welgun therefore inherited those magazine liabilities from Sten. Young agent training included magazine inspection routines. Training had to be repeated under stress. Briefcase deployment demanded fine motor control. Cold hands slowed assembly speed markedly. Wet conditions complicated grip on small parts. Small latches were hard to manipulate quickly. Stock lock failures produced unstable firing posture. Hinge wear enlarged stock wobble over time. Receiver tube dents impeded bolt travel. Tube dents could occur during parachute drops. Case impacts could deform thin, stamped parts. A protective sleeve was not always used. Spring fatigue reduced return energy after cycles. Springs were made from music wire stock. Heat treatment cycles controlled final spring temper. Quality control sampled spring force with gauges. Bolt face erosion occurred with primer blowback. Primer cratering was seen with some ammunition. Firing pin protrusion required tight limits. Excess protrusion risked pierced primers and gas leakage. Pierced primers vented gas into receiver. Gas venting accelerated internal fouling deposition. Fouling combined with lint in carry cases. Lint accumulation affected sear engagement surfaces. Sear contamination risked failure to reset. Failure to reset produced dead trigger events. Agents were instructed on basic clearing drills. Clearing drills needed safe muzzle discipline. Compactness reduced safe handling margins during hurried manipulation. Short overall length increased muzzle swing risk. The trigger guard was small and cramped. Gloved use became unreliable in winter. The weapon accepted no suppressor standardization. Some trials explored improvised sound reduction. Threading changes risked baffle strikes during suppressor trials. Subsonic loads were not consistently supplied. Unsuppressed 9mm remained loud in rooms. SOE missions valued discretion over sustained fire. Welgun doctrine focused on short bursts. Burst control relied on stock shoulder contact. Recoil impulse was mild but abrupt. High cyclic rates drained magazines quickly. Sten magazines held 32 rounds nominally. Full magazines increased insertion resistance at the magwell. Insertion resistance delayed reload under pressure. Magazine release could be pressed accidentally. Accidental release dropped magazines on the move. Dropped magazines dented feed lips easily. Agents carried spare magazines in cloth pouches. Pouch lint entered magazine bodies readily. Magazine follower tilt caused inconsistent feeding. Follower tilt worsened with sand contamination. Sand entered through magazine witness holes. Witness holes were sometimes taped over. Tape residue attracted more grit and dust. Cleaning kits were minimal for covert loads. A pull-through cord cleaned barrel quickly. Receiver cleaning often required disassembly tools and time. Tools conflicted with low-profile carry. Field manuals recommended bench cleaning when possible. Bench cleaning was rare during operations. Station 9 testing used controlled range firing. Range logs recorded stoppage rates per magazine. Tests compared different magazine batches for stoppage rates. Tests also compared lubrication regimes under controlled firing. Extreme cold trials were limited in Britain. Hot weather trials relied on foreign reports. Drop tests evaluated case protection adequacy. Drops from truck beds caused latch damage. Latch damage prevented secure case closure. Loose cases revealed components to inspection. SOE concealed cases among civilian luggage. Civilian luggage constrained weight and hardness. Welgun mass was kept relatively low. Weight was documented around 7 pounds assembled. Weight balance was front-heavy with short stock. Front-heavy feel slowed target transitions. Magazine forward position shifted center of gravity. Forward magazines complicated prone firing position. Prone shooting required elbow clearance for magazines. Elbow clearance was limited in narrow cover. Vehicle use benefited from short overall length. Tight spaces still challenged muzzle awareness. Recoil spring replacement was not field-friendly. Spring ends needed precise seating in guides. Mis-seated springs caused scraping and drag. Drag reduced bolt velocity and ejection. A weak ejection produced stovepipe malfunctions. Ejection port area had minimal shielding. Casing bounce back could re-enter port. Bounce back risked bolt override stoppages. Bolt override demanded immediate remedial action. Remedial action took time during contact. SOE agents preferred simple, immediate action. Welgun procedures were more complex than pistols. Pistols required no assembly from cases. Pistols also allowed faster one-handed use. Welgun offered higher hit probability at range. Shoulder support stabilized sight picture during short bursts. Longer sight radius improved alignment consistency for operators. Even so, sights remained rudimentary on most examples. Rudimentary sights limited practical accuracy beyond closed distances. Accuracy was adequate inside 50 yards. Beyond 50 yards, dispersion increased under imperfect lockup. When dispersion increased with loose stock joints, joint tolerances varied between production batches. Small batch production reduced statistical consistency. Production used mixed subcontractor supply chains. Subcontractors delivered stampings to central assembly. Tube receivers came from different machine shops. Interchangeability goals were only partly met. Fitting was sometimes required at assembly. Hand fitting increased unit labor hours. Higher labor reduced procurement attractiveness within competing budgets. SOE budgets competed with other clandestine items. Sten guns were already in mass production. Stens were cheaper and widely understood. Welgun offered concealment but needed cases. Cases added cost and logistic burden. Cases also had to be disguised plausibly. Disguise selection depended on mission cover stories. Some covers used tool cases or musical cases. Unusual cases raised suspicion at checkpoints. Checkpoints searched for dense metal objects. Welgun components created distinct weight signatures. Metal detectors were rare, but manual searches were common. Manual searches found odd-shaped parts easily. The briefcase concept worked best pre-search. Pre-search meant cases stayed closed until needed. Combat use often followed sudden contact. Sudden contact reduced time for assembly. Assembled carry was difficult under clothing. Stock and receiver printed through fabric. Printing risked compromise in urban settings. Urban settings were common for resistance work. Rural missions had more concealment options. Rural carriage still faced moisture issues. Moisture promoted corrosion on bare steel. Phosphate finishes were applied to limit rust. Finish quality varied with bath composition. Poor phosphate adhesion led to flaking. Flaking contaminated moving parts internally after rough handling. Internals demanded clean, sliding surfaces to avoid drag. Bolt rails were minimal in tube designs. Minimal rails depended on smooth tube interiors. Tube interiors required reaming and honing. Honing tools were scarce under wartime constraints. Rough interiors increased friction and stoppages. Station 9 requested better finishing allowances. Production managers resisted extra machining steps. Extra steps slowed output and raised costs. SOE procurement accepted limited numbers for trials. Trial issue went to selected agents. Feedback returned through debrief reports and technical notes. Debriefs noted assembly difficulty under darkness. Darkness was common during clandestine movement, so agents used tactile indexing for parts. Indexing features were small and subtle. Small features wore down with repeated assembly. Worn indexing caused misalignment on insertion. Misalignment could cross thread barrel nuts. Cross-threading made further assembly impossible. Agents were told to avoid forcing parts. Avoiding force slowed assembly under pressure. The trigger pack used simple pins. Pins could walk without proper staking. Staking quality varied between assemblers on rushed lines. Walking pins altered trigger geometry during repeated folding. Altered geometry risked unintentional discharge under partial sear. Unintentional discharge was a severe operational hazard. Safety reviews emphasized conservative sear engagement. Conservative engagement increased trigger pull distance. Longer pull reduced first shot speed. Yet first shot speed mattered in close quarters. Close quarters were the likely employment range. Welgun was not intended for long firefights. Magazine capacity still tempted prolonged firing. Prolonged firing heated the short barrel quickly. Heat increased mirage and handling discomfort. Heat also increased chamber cook-off risk. Cook-off risk remained low in 9 millimeters. However, hot chambers increased extraction drag. Extraction drag caused torn case rims. Torn rims required tools for removal. Tools were rarely available in the field. Station 9 tested different extractor steels. Harder steels resisted wear but risked brittleness. Brittle claws could chip on hard primers. Chipped claws failed to extract reliably. Replacement required armorer intervention under controlled workshop conditions. Armorer support was limited for agents. SOE favored throwaway simplicity in many devices. Welgun did not fully meet that simplicity. The folding stock hinges demanded precise machining. Precise machining conflicted with emergency manufacture. Emergency manufacture favored broad tolerances across multiple subcontractors. Broad tolerances harmed repeatable lockup at the hinge. Repeatable lockup affected Site 0 retention. 0 retention mattered after repeated takedowns. Agents often reassembled without re-zeroing fixed sites. Therefore, fixed sites were a compromise. A folding rear sight was considered unnecessary. Some prototypes used different sight notch widths. Notch width affected speed of alignment. Wider notches aided low light use. Wider notches reduced precision at distance. SOE prioritized fast center mass engagement. Center mass engagement aligned with 9 mm ballistics. 9 mm drop is moderate at distance. Drop estimation was not part of training. Training time was scarce for operatives. Scarce training favored familiar weapons already issued widely. Many agents had seen Sten operation. Welgun felt similar, but not identical. Differences included stock lock and takedown. Takedown introduced new failure opportunities during rushed deployment. Failure opportunities multiplied under combat stress. Combat stress reduced fine motor coordination. The case itself introduced handling problems. Case handles could break under load. Broken handles forced awkward carrying methods. Awkward carry increased accidental drops during hurried movement. Drops increased alignment damage risk for barrel interfaces. Some reports noted cracked wooden inserts. Cracked inserts allowed metal to rattle. Rattle created noise during movement through occupied streets. Noise compromised stealth in occupied areas. SOE requested quieter packing solutions for covert carriage. Quieter packing reduced rapid access speed. Padding could snag on small parts. Snagging delayed assembly and deployment during nighttime actions. Delays reduced tactical value during contact. The weapon's external profile looked improvised. Improvised appearance was not a design objective. Aesthetic concerns were secondary to concealment, yet appearance influenced user confidence in equipment. Low confidence reduced willingness to carry it. Users preferred trusted pistols and knives. Pistols also fitted common holsters used by agents. Welgun required bespoke concealment equipment and dedicated cases. Bespoke equipment increased supply chain complexity. Complexity reduced sustained procurement orders from SOE offices. Only limited production quantities were authorized. Numbers remained far below Sten totals. Documentation remained classified for many years. Post-war evaluation highlighted niche usefulness for specific roles. Niche usefulness did not justify standardization. British services already selected other carbines. Later compact weapons used different folding concepts. Many later designs integrated folding without takedown. Integrated folding reduced assembly steps for users. Reduced steps improved readiness under surprise contact. Welgun represents a constraint-driven engineering trade. Constraint reduction required compromising ergonomics across several interfaces. Ergonomic compromises affected shoulder interface comfort. Comfort influences controllability during automatic fire. Controllability affects practical hit probability under automatic fire. Hit probability drives perceived weapon utility. Utility drives procurement decisions under wartime budgets. Budgets favored scalable, rugged solutions with low training. Ruggedness requires tolerant magazines and sealing. Sealing was minimal in Welgun architecture. Minimal sealing suited workshop rather than mud. Mud exposure was likely in field conditions. Field conditions also included improvised storage. Improvised storage risked rust and denting. Dent resistance was low with thin stampings. Stamping thickness was selected for weight limits. Weight limits aligned with agent load constraints. Agents already carried radios and explosives. Explosives demanded careful packing and protection. Welgun competed for space with mission items. Space competition favored multi-use tools over single weapons. Welgun was single-purpose in most missions. SOE therefore treated it as optional. Optional gear sees reduced training investment. Reduced training worsens real-world reliability. Reliability concerns fed back into procurement caution. Procurement caution limited iterative improvement opportunities. Limited improvement kept the design rough. Roughness preserved the nickname folding carbine. The briefcase concept remained technically valid. The implementation needed more production refinement. Refinement required time and stable factories. Time and stability were scarce in 1943. Therefore, the program stayed experimental in scale. Experimental scale reduced user familiarity further. The design still influenced later compact arms. Such influence came through lessons on assembly burden. Assembly burden is a measurable operational cost. Operational cost includes seconds under threat. Seconds under threat are budgeted in training plans. Training plans for agents were condensed modules. Condensed modules favored muscle memory drills. Muscle memory needs repetition with real hardware. Hardware availability limited repetition opportunities for trainee agents. Limited opportunities increased assembly error rates. Error rates were observed in range trials. Range trials also measured group sizes. Group sizes widened with loosening joints. Joint loosening followed thousands of folding cycles. Cycle testing was not exhaustive for all units. Some units left factory with tight hinges. Other units arrived with perceptible play. Play increased during transport and handling. Yet transport vibrations worked pins and screws loose. Overworked inspectors missed subtle alignment faults. Alignment faults showed as feeding angle problems. Feeding angle problems increased stoppage frequency. Stoppage frequency undermined confidence in the system. Confidence loss reduced repeat deployment in missions. SOE logistics noted low reissue demand. Low reissue demand ended follow-on contracts. The Welgun remained a specialist artifact. It demonstrates that concealment adds mechanical steps. Mechanical steps create more failure modes. Failure modes appear during dirt and shock. Shock loads occur during escapes and drops. Escape scenarios allow little time for assembly. Therefore, pistols stayed the dominant concealed arm. Compact carbines returned only with better engineering.